Airplanes, how they go, do you know how they go in and out of Cleveland? Obviously they fly, but how do they avoid smacking into each other? Well, Tom Haley visited a place that's not far from Cleveland that controls all these airplanes, and he visited this air traffic control center.
478 Alpha Delta's radar contact 10 miles northwest of the Morgantown VOR. Climb will maintain 8,000. Okay, we're on 6 going to 8. 478 Alpha Delta flying heading at 340. Vectors to intercept Victor 37. Advising you intercept the airway. Say it again, the heading? 340. Heading 340. Vectors to intercept Victor 37. Roger, heading at 340. Crispin 203 is cleared to the Parkersburg VOR. That's your clear.
The world's largest air traffic control facility. Do you have any idea where that is? Would I surprise you if I told you that was in Oberlin, Ohio? I kind of thought I would. Let me tell you why it's the largest. I have a few statistics here. It handles, this is the Cleveland Air Traffic Control Center, handles over 2 million planes a year. Count them. They're not all up there right now. And on one peak day last August, it handled over 8,000 planes. Now you might say, what do we mean it handled these planes? Well, when did you fly last? Most of us now, when we go anywhere, any distance, we fly. It's kind of comforting to think that it's safe, huh? Well, such a center is one of the reasons why it's safe. But I think what we should do together, you come with me, we'll go inside and meet Dan Smith, who's an air controller and is also a public relations man with PATCO, which is the Air Controllers Union. So let's go inside together. Dan, I've always thought of this air center as one that controls planes that fly, not going into Hopkins, but just fly over this area on long-distance flights. I think that's what the civilian thinks about it. Is that correct?
Well, basically, that is one of the functions that we do provide. It's an en route service that we do provide, the aircraft overflying the area. We do provide other services here also. We do work with approach controls at Pittsburgh, Cleveland, Detroit, Buffalo. We line up the traffic for the landing sequencing for the approach controls. We have to get them in an in-trail.
Okay, if I'm flying into Hopkins, coming in from New York or wherever, you do have something to do about that plane up to a certain point.
That's correct. Up to about 30 miles from the airport, that is our control jurisdiction.
What do you do then? Turn it over to the tower at Hopkins?
That's right. We talk to the controller at Hopkins at approach control, and we tell him where the aircraft is. When he acknowledges the position of the aircraft, then we change the frequency. We change the aircraft over to their frequency so they can talk to him and finish the process down to the ground.
Okay, we showed out in front, it said the world's largest air traffic control center, or words to that effect. Why so much more traffic here than in other centers in the world?
Well, it's because of our location, really. The center, Cleveland Center, being located in Oberlin, is located right in the center of what has in the past been referred to as the Golden Triangle, and that's the piece of airspace that runs from Chicago to New York and from Washington back to Chicago. And those are the two busiest airways running between those points, run right over Cleveland, Ohio, right over Cleveland Center.
Okay, I see a number of states involved here. I recognize Ohio, that's an easy one. And you have parts of Pennsylvania, part of West Virginia, New York. Does Michigan come into it? Yeah, Michigan
does.
That's right. So you have, what, parts of Maryland? How many states, you said?
Parts of 9 states, all of Lake Erie, and part of Ontario, Canada. We do control some Canadian airspace also.
Well, the place is busy. I took a quick look when we got here. How many air controllers do you have here?
Well, controllers, we have approximately 530. We have new people coming in, some leaving all the time, transfers, retirees. So,
Dan, I understand one of the difficult parts of this job is that you're always changing shifts, that you work one week from 8 to 4, another week from 4 to midnight, and then the one after that from midnight to 8 in the morning. Now, why do you have to change shifts that often?
It's probably the best way to equally distribute the workload. Different areas have different peak workload times. And if an individual always worked during a light traffic period, he would not be doing the same job or have the same responsibility as an individual that always worked heavy.
What you're saying to me is this is a way to keep his skills at maximum efficiency.
That's right.
Okay, Dan, at least we know what this is all about. We know people are trained here. We have an idea of your job. One thing that I do notice on here, we see all the screens around the place, but you have settings that look like radar. How many radar places are there?
There's 7 radar antennas that we get our information from for our computerized radar displays.
See, that's something the average person doesn't realize. You see the screens down there and you see the blips on them, or whatever you want to call them, but you forget you got to have the radar sights, don't you?
Right, that's right. The radar is the primary tool that we use for the separation of the aircraft. That allows us to see them and provide the service. And then, of course, the remote air-to-ground communication sites located throughout the area is what allows us to talk to the aircraft and put into effect the separation that we see necessary on the radar.
Right now we're in a control room at the Traffic Control Center in Oberlin, and we're looking at a radar scope. Is that what it is, Dan?
That's correct.
What are you seeing on that at this moment?
Well, the way the display is set up here, we're looking at a sector, a block of airspace to the southwest of Pittsburgh. It's one of the small sectors, small sections of airspace that is set up for the control of aircraft.
All right, on this screen, the radar screen, are there aircraft there at this moment?
Yes, there are.
Point some out to me.
All right, the lines, the diagonal lines that are on the scope here are all aircraft. Those designate aircraft, and then they have the alphanumerics, the numbers, identifying numbers following them.
All right, now you have something here you can use. You have something you turn here, and that takes a little zero, and that's sort of a pointer for you. I'm using civilian terms. I don't know one from another. Show me how that works.
All right, well, the marker, which is located right up here now,
it's right here. Okay.
It's a means of identifying aircraft to the computer. It's a means of telling the computer that we're talking about a specific place or aircraft. And
all right, so the computer finds that out. What does that do for the computer?
Well, if we want to talk to the computer about this particular aircraft, I can identify the aircraft by marking it like so. It's just another means of identifying the aircraft.
What happens if the radar isn't working? Suppose you lose power out here.
Well, we have a backup radar system, which is not helped if it's a power outage. Power outage would leave us with just the radios as long as they were still functioning. The power outage problem has been pretty much alleviated by means of our own generators. We have our own generating capabilities located in the building out and back, and we have our own storage batteries that have enough power to operate the system until we can get the generators started if we lose the external commercial power.
Dan, we talked about this being the world's largest air traffic control center. And I suppose a natural question is there maybe too much traffic for it? If, you know, there's such a big place, is there ever a time when there's too much?
For traffic?
Yeah, is there too much traffic for this center?
Well, sometimes it seems that way.
Because sometimes we're told that the centers aren't large enough for the amount of air traffic there is today.
There are times when the amount of traffic that we have to handle is more than what can be handled in a safe, orderly, and expeditious fashion. And in those times is when we run into delays. Aircraft are restricted from entering the airspace. If we have too many, if I'm working this particular sector and I feel that I have reached my point of saturation, I have now taken all of the aircraft that I can safely handle, I will not take more traffic. Provisions are made to restrict the flow of traffic entering my airspace.
Hey, you've got a lot of lives there that you're sort of trying to be sure remain lives.
There can be pressure involved with it. A lot of times the pressure will come after you're done working through a busy session. To sit at the position and be concerned about the number of lives or the number of people that are under your control at the time is not what actually happens. You're separating airplanes, you know that you're responsible for lives, but you don't think of it in terms of how many lives are depending on it at the time.
Dan, air traffic controllers are human, like anyone else, so they do make mistakes, and I've seen some FAA figures that quote a number of mistakes in 1978 and some more in 1979. Now, I don't know what they mean by mistakes. What is a mistake that an air controller could make?
Included in there would be anything less than